Here we go.
Hello everybody, here is my new video. In this video we will learn how to write a word and a balanced chemical equation for a given reaction. And here we start with question 1. In question 1, write word and balanced chemical equations for the following reactions. Include symbols for physical states when indicated. Here we should know all the correct symbols, formulas, and states for the chemicals given in the chemical reaction. Solid magnesium reacts with sulfuric acid solution to produce hydrogen gas and magnesium sulfate solution. First of all, I'm going to write the word equation for this reaction. Word equation. Solid magnesium reacts with sulfuric acid to produce hydrogen gas. You can write hydrogen and magnesium sulfate solution. And in the second question it says write a balanced chemical equation for the following reaction. So this is the most important part of the question. We will use the symbols and chemical formulas to write our formula equation, or in other words we can say this is the chemical equation. Let's write chemical equation. And here the state of magnesium is solid. The symbol for magnesium is Mg. Its state is solid, indicated by small s written to right down corner of the symbol. Reacts with sulfuric acid. It is H2SO4, and it says its solution, so its state will be aqueous, AQ, shown by AQ, to produce hydrogen gas, H2 gas, and magnesium sulfate. Magnesium, the oxidation number for magnesium is +2. Sulfate is SO4 2-. You cross over the charts. Mg2 in the parentheses SO4 2 can be cancelled. Then you can get the formula of magnesium correctly as you see on the paper. MgSO4. Its state is aqueous because it says magnesium sulfate solution. It means our magnesium sulfate dissolved in water. Now, question wants us to write the balanced chemical equation. For this reason, we must count the number of atoms on both sides. The left side of the arrow is called as reactants. The right side of the arrow is called as products. I have one magnesium atom on the left side, one magnesium atom on the right side. 2 hydrogen atoms on the products and reactant side, 2 hydrogen atoms on the right side. And also we have one sulfate group on the reactant side, and I have one sulfate group on the product side. So this is a balanced chemical equation. This is balanced. In question B, potassium bromide solution reacts with silver nitrate solution to produce potassium nitrate solution of silver bromide and silver bromide precipitate. And this is going to be and silver bromide precipitate. First of all, let's write the word equation for this reaction. Word equation. Potassium bromide reacts with, means plus, silver nitrate to produce potassium nitrate and means plus silver bromide. Silver bromide. Okay, now we will write the balanced chemical equation. Chemical equation. It means we will write the formulas and the symbols for the reactants and the products given in our reaction. Potassium bromide, the oxidation number for potassium is plus, right? K plus. Bromide is Br minus. K plus and Br minus make a compound in each other, and the formula becomes KBr. The state for this compound is aqueous because it says in the question potassium bromide solution. It means potassium bromide dissolved in water, and its state became AQ. Plus silver nitrate. Silver nitrate, its formula can be written like this. Ag, its charge is +1. Nitrate, it's a polyatomic ion, its charge is minus. Cross over the charge, get the formula AgNO3. And its state is aqueous, shown by AQ. And they react to form potassium nitrate solution, KNO3 solution, and a precipitate of silver bromide, silver bromide. It's a precipitate. For this reason, let me give the definition for a precipitate. A precipitate is a substance that is obtained from the aqueous solutions of chemicals, and always its state is solid. Okay, now let's count the number of atoms on both sides. One potassium atom I have on reactant side. On the product side, I have one potassium atom, one bromine, one silver, one nitrate group. So this reaction or this equation is a balanced chemical equation. In question 2, we're going to translate the following equations into sentences. Here, actually, we're going to do the reverse of what we did in the first question. I have liquid carbon disulfide and oxygen gas. They react to form gaseous carbon dioxide or carbon dioxide gas and sulfur dioxide gas. To write a sentence between reactants and what's happening in the reaction, you must recognize all the chemicals and you must give the correct names for the chemicals given in the equation. For this reason, naming a compound plays a very important role in these kind of questions. Okay, let's write the sentence that best describes the chemical equation. Let's write carbon disulfide. This is a molecular compound. For this reason, we use monoditri. Both of them are nonmetals. Both carbon and sulfur are nonmetals. For this reason, we use di-monotri in naming of these kind of compounds. Carbon disulfide in liquid state reacts with oxygen gas to produce carbon dioxide gas. Here also you can see we use monoditri because both carbon and oxygen are nonmetals. For this reason, naming of binary molecular compounds contains Latin numbers monada, which are monadi, tri, tetra, penta, hexa, hepta, octa, nona, deca, and so on. Carbon dioxide gas and sulfur dioxide gas. Okay, that's it. Here is our sentence which describes this chemical equation. Carbon disulfide in liquid state, reacts with oxygen gas to produce carbon dioxide gas and sulfur dioxide gas. Here the coefficients 1, 3, 1, 2 has no effect in the writing of sentences because we do not use them. We use the coefficients for two purposes. One, to balance our chemical equation. Two, to find the more numbers of chemicals given in our chemical equation. In question B, we have aqueous solutions of sodium chloride and silver nitrate. They react to form aqueous solution of sodium nitrate and a precipitate of silver chloride. As I told you in the solution of question B or question 1, a precipitate is a product of reaction between aqueous solutions of chemicals, as you see here. So silver nitrate is going to be a precipitate in this equation or in this reaction. Okay, let's write aqueous solutions. Instead of aqueous solutions, you can write water solutions, or sodium chloride dissolved in water reacts with silver nitrate dissolved in water to produce aqueous solution or water solution of sodium nitrate and a precipitate of silver chloride. Let's write in this form: aqueous solutions of sodium chloride and silver nitrate react to form or to produce aqueous solution of sodium nitrate and a precipitate of silver chloride. Okay, thank you. Here in this video we learned that what's the meaning of precipitate and how can we prepare a solution between a chemical and water, and what's the name for this state. It is aqueous solution. And also we learned how to write a word equation for a given reaction, and also we learned the names of parts in any chemical equation, which are reactants and products. And also we have learned that how to write a correct chemical equation, correct balanced chemical equation between reactants, and how to write the products for a reaction occurs between reactants. Okay, thank you so much for watching.